Your application works perfectly fine until real users start using it. And suddenly, slow APIs, multiple crashes, total downtime. Why does it happen? Because every system has hidden bottlenecks, and most engineers ignore them while building the application. Let's start simple. So the typical architecture where probably you would be using a monolithic architecture, single server, single database, single file storage, cache also on the same server. Everything is fine. Everything is simplified. No more costs are required to maintain. But there are a few problems with this kind of architecture: tight coupling between the components, shared resources, and single point of failure. Meaning if a system is down, it will be down for everyone. There will be 100% downtime. If there will be high computational tasks, then it will start blocking. You will see lots of deadlock problems, heavy processing APIs. You will also see heap overflows because every hardware has having limitations. They can only take a load up to a certain extent. After that, you will start seeing the slow queries, missing indexes, connection pool exhaustion, right? You will also see disk read and write latency. All of these problems you might face on a single server when user starts growing up. It will work perfectly fine up to, let's say, 1000 users, but as soon as your user starts growing up, it will start showing the problems, right? Then the scaling comes into the picture. So while we want to scale, the very first option engineers or architecture prefer is vertical scaling. It is cheaper as compared to the horizontal scaling, because what we're doing here is just upgrade current server. Do not add anything additional, just upgrade the CPU. It will help you to buy the time till a certain extent. You can increase the CPU, RAM, SSD, right? And then you will still be having the simplicity which a single server provides. But that can only help you up to certain number of users. As soon as your users starts growing up, you need to start adding multiple hardwares. You need to start creating a distributed environment, right? And then the horizontal scaling comes into the picture, which is scale out. What is it? It adds more server instead of the bigger servers. Now, because you have added more servers, you need to start adding the load balancer. There will be multiple algorithms you will have to introduce to identify where to redirect the traffic, on which server to redirect the traffic. Benefit of this kind of scaling is fault tolerance. Even if the one server is down, the other servers are still up. So user will not see complete 100% downtime, right? High availability would be provided. And if in future traffic grows, you can keep adding more servers, and there will be certain days when traffic start reducing, you can start removing the servers. So you will be having a elasticity of scaling, right? It is basically a distributed system design. But it also has its challenges, because now the data are distributed in multiple servers. You need to maintain the data consistency. You need to maintain the network latency. You need to maintain the coordination between all of the servers, right? If the data are available in one server, or if the right operation has been performed on one server, then the same needs to be replicated in all the other servers so that user doesn't see any stale data, right? But in most of the organizations, they generally use the combination of vertical and horizontal, which is called the diagonal scaling. So basically, they divide the component, they divide the monolithic architecture in multiple components, and based on the need, they start adding the CPUs or they start adding the RAM in that particular part. If only database is having a heavy operations, they only scale the database and they don't touch the other part. So if you see here in horizontal scaling diagram, we see that user, as soon as user enters into application, the first they will go into load balancer, right? And then the load balancer will decide where this user request should get served in first server, second, or third one. And then it will go into the Redis cache or the database part. Now, if you see in certain days, let's say some sale is going on or some festival is going on, and now you are expecting more users to come on your website, then you need to scale your database for those particular days, right? Then you can increase this capacity, and then as soon as this festival gets over, you can go back to the original implementation, right? So that's how it works. There are multiple ways of database scaling. You can scale the cache layer, you can scale the read application, or you can scale the messaging queue. It depends on your use case. There are multiple ways of doing it. So for the millions of users, this could look the final architecture. So very first thing, they will reach to the DNS. I'm going to create a separate video for DNS. Then they will go to the CDN. CDN will help you to route your users for different regions, and they can balance the load per region. I'm also going to create a separate video for CDN, and then there will be API gateway. So you need a gateway where you can control the traffic, or you can for each and every APIs you need is one common platform where you can add the security or rate limiting, routing, all that stuff. You need to maintain it one place, and that is your API gateway. So after passing through the API gateway, now based on your use case, user will go into different platform, right? And then it will reach to the real database, and your response will be served back to the main application.